In this short lecture, we'll discuss the idea of continuity, which is one of the most important concepts in mathematics. Being a continuous function is one of the crucial conditions of a lot of theorems and major applications. Well, as people say, a function is continuous if you can draw the graph of the functions without lifting the pen. So on a certain intervals, if you can graph a functions without lifting the pens, then the function is continuous, right? Until you have to like stop, pause, and lift it up, and then start it again. And that means the function is not continuous at this point. So the continuity tells you the smoothness of a function. So how is continuity defined? So a function f of x is continuous at a point x equal to c if the three conditions are satisfied. So the three conditions for a function to be continuous at a point c. So the very first and foremost conditions is the point, f of c is defined. And then the limit when x goes to c exists. And the last condition is the value at c equal to the limit when x go to c. All right, keep in mind that there's three conditions for a function to be continuous at a point. Now we can look at the graph here. Well, let's look at the point when x equals to -10. At this point, you can see the graph is smooth through this point, right? And apparently f of 10 is defined. The limit when x goes to 10 to -10 exists, because if you taking x values from both sides, they both go into the same point, and the value of f of -10 and the limit when x go to 10 is the same. So at the point x equal to -10, the function is continuous. How about when x equals to -5? When x equals to -5, we see that we have an open circle here, which means f of -5 is undefined. So if it's undefined, then it violates the very first conditions. That means the function is not continuous at x equals to 5. So the first conditions, right, violated. How about when we go to the point where x equal to 0? X equal to 0, f of 0 is defined and it is this point. But the limit doesn't exist because x goes to the left from the x goes to 0 from the left is not the same as x goes to 0 from the right. So the limit doesn't exist, which means at x equal to 0, the function is not continuous. All right. Then, and it's because of the second conditions. All right. Well, look at the point where x equals to 4. F of 4 is not defined because x equals to 4 is a vertical asymptote. So the first condition is not satisfying. The second condition is also violated because the limit when x goes to 4 is not, doesn't exist. So that means the function f of x is not continuous at x equals to 4. And it's because of the first, probably all the conditions are not satisfying, right? So all conditions. So we look at this graph, we found there's some discontinuities here. And we found that there's 3 discontinuities. First, it happens when x equals to 5. Second, it happens when x equals to 0. And third, it happens when x equals to 4. And any other values of x besides these three values, the function is continuous. At this point, the function is continuous at this point. Points on this graph, the function f of x is discontinuous.